Okay, so let's continue with the lecture on the bus implementation for RTL. Okay, so basically in RTL, we normally do a bus implementation. So let's do a basic comparison. So I think you can read this through yourself. I'm just going to go through quickly here. I think we'll go more detail in the example later. But basically there are two different kind of implementation. You can have a direct implementation and a bus-based implementation. Okay, so in the bus implementation, basically what happened is we are going to have a bus. Okay, basically it's a single line, and the idea is to have only a single register output on the bus. Okay, and that we control using some control signals. Okay, for example here load X. So if load X is 1, then we are going to transfer Y to the bus, okay, instead of X. So basically a bus then is essentially a mechanism to select the output of the register to do some of the processing. Okay, so let's look at a simple example here of what it means by a bus implementation in RTL. Okay, so here for example we have 4 registers, okay, R0, R1, R2 and R3. Okay, and the registers here output actually this is a multiplexer, and let's say for example here, okay, we want to have R0 on the bus. Okay, so how do we transfer R0 to the bus line? So here is actually a multiplexer, and let's say here is a 0, 1, 2, 3, and then we have a select here. And if I put select equals to 3, then what happens is I'm going to take the R0 and put it inside the bus, and therefore here will be R0. Okay, what happened to R1, R2, R3? So R1, R2, R3 will be stuck here. Okay, it's going to start here, it's not going to go through the bus. Okay, when I put 3, R0 will go to the bus. Okay, let's look at one more example, and let's say if I put my select equals to 1. So if I put my select equals to 1, then R2 is going to transfer there, therefore R2 goes to the input of all the registers. Okay, so essentially this is a bus, and the value that we put on the bus depends on the value of the select that we put on the control. Okay, so let's look at one example here. Let me just do this. Okay, so this is a bus implementation with a real multiplexer, and also actually here if you see we also have a load signal connects to the enable of the register. So what it means by the enable of the register? So enable of the register means that if enable equals to 1, then we're going to load register. Okay, it means that the register is active. So for example, if for example I put a 1 here, 0, 0, 0, okay, and then I'm going to put the value of X here. Okay, I'm going to put the value of X there. So what happened to our output, our register output? Okay, so the register output here is going to be X. Okay, here is going to be R1. Okay, it's not going to take X. Okay, because our load is 0. Here is R2, here is R3. Okay, so X gets to transfer inside here only in the register R0, because we set the load here equals to 1, all the others are 0. Okay, so basically the load is saying that whatever is on the input will be put inside the register if enable is equals to 1. Okay, so the interesting thing here is let's try and write the Verilog code for this data path. Okay, here we call it essentially this is your data path unit. Okay, here is your data. We're going to see this more later on. So but here is called the data path unit, and we can actually write a Verilog code for this one. So let's try and make a simple exercise to write the Verilog code for this design. Okay, keep it bigger than that. Okay. So module, so you can say module bus, let's call it circuit 1, circuit bus 1. Okay, and we can have our input. Obviously we're going to have a clock and reset, where reset is not there, so just clock. Okay, what else we have? We have input, load. Okay, so we have load R0, load R1, load R2, load R3. Okay, so we already defined our input, clock, done, load. What else is our input? Select is also our input, so you can say input 10 select. And any other? So no, I think we don't have output. Okay, for this particular example we don't have output. It's not practical, just an example. Okay, do we have any internal wire or reg? Yes, we have. So here we have reg. Okay, and it's a 4-bit register. How do I know it's a 4-bit register? Well, here you can see it's a 4-bit, so it's 4-bit coming in. So it's a 4-bit register, R0, R1, R2, R3. Okay, these are the output of the registers. And we also have a wire, a 4-bit wire called A bus, okay, which is this guy. Okay, so this done. Okay, so we define already our input outputs, no output. We define the internal wires and registers, and now we can write our always block. There's many ways to do this. I think the solution in the book is a little bit different. I'm going to do a little bit different than the book. Okay, again, there's no reset. And remember, inside here, this is going to be our register. So what is the output of the register? So it's simply that R0 A bus. Okay. Hold on, let's do something like this. Okay, so the register now actually depends on our load. So we say if load R0, okay, enable, then only we say R0 is a bus. Okay, okay, that's it. So if load R1 equals to a bus, if load R2 is a bus, if load R3 a bus. Okay, so I think we can see here that the output of the register is only taking a bus if and only if the load is enabled. Okay, if the load is 0 or not enabled, then that register will maintain the previous value. Okay, it will not take the new value from the A bus. Okay, so we put N there. Okay, so is that complete? No, we haven't defined the marks, so let's define the multiplexer. So let's use another always block here, always add, select R0, R1, R2, R3. Okay, so these are the inputs to the multiplexer. So you can say case select, and if select is 0, then our A bus is going to be equals to, so 0 is taking this guy. Okay, 0 is taking R0. Okay, so this one is R0. Okay, 1 A bus is R1. Okay, I think 1 you can see here, 1 is R1, 2 is R2, 3 is R3. So 2 A bus R2, 3 A bus R3. Okay, so I think that's complete. We have defined everything. The clock is there, the load, the select is done, and module. Okay, so you can see there's two parts here. Okay, so here we define our multiplexer, and here we define our registers. and then we combine them together, and you can see the A bus here is combined here. Okay, so essentially what happened here is based on the selected value. Okay, based on the selected value, we are going to put a certain value on A bus. So if the selector is 0, we're going to put R0 on the A bus. If the selector is 1, we put R1 on the A bus. And then we're going to check the load. If load is R0 is 1, then we take the value of the A bus into R0. Okay, so basically it's a implementation of the bus. And I think I want to mention a little bit more here on the on this part here, on the register RTL timing. So let's look at the example on what it means by the timing of the RTL. Okay, so let's see. Let's say for example here we have let's say for example here I have a state 0. Okay, I have state 0, and in state 0 I want to transfer the content of R0 into R1. Okay, I want to transfer R0 into R1. So where is R0? R0 is here. Okay, I want to put this value, I want to put it inside here. How do I put my R0 into R1? How do I put R0 into R1? Okay, so what should be load okay, what should be select. Okay, so what do we set? On this guy, this and this, so that we can successfully transfer R0 into R1. Okay, I want to transfer that inside. Okay, so we can see that if I want to transfer R0 into R1, means that I have to go through like this. I have to go through all the way like this. Okay, which means that my select should be equal to 0 because I want to take this. Okay, my select should be 0, and then my load R1 has to be equals to 1. Okay, so it means that if select is 0, if I put 0 here on the select, 1 here on the load R1, then it's going to put my R0 inside R1. Okay, and all the rest, so load R0 is 0, okay, load R2 is 0, load R3 is 0. Okay, so this is the control signal, signals to do this RTL operation. Okay, so if I want to transfer again, so I want to transfer R0 to R1. Okay, so then I need to set my select equals to 0, and I need to set my load R1 equals to 1, and all the rest will be load R0 is 0 because I don't want to put R0 inside R0. Here also and it needs to be 0 because I don't want to put inside, R0 inside R2, and here is also 0. I don't want to put R0 inside R3. Okay, I just want to put R0 inside R1, therefore load R1 is equals to 1, and selector is 0. Okay, so this is the main concept. This is the main idea that you need to understand. On the RTL, the register transfer is basically based on select and the load. Okay, how do we play around? How do we set our select? How do we set our load so that we can successfully make the register transfer that we want? Okay, so that's what's been discussed here in the next part of the book here. Okay, so I think you can read this through yourself. We'll look at more examples later on. But here you can see that if you want to do this is the select and the load operations that we need to do. Okay, so I think that's it for this part, and we'll continue next on the RTL architecture and the design flow.